Alright, these two examples are going to be very similar to the previous two, just a little more complex in what we need to do. So I'll, as you guys work on them, I'll set them up and let's check your work against what I have. So for this first one, every place we see an f of x, I have to substitute in using the difference quotient, f of x plus h minus f of x all over h. Now, hopefully you remember to be able to simplify this, I have to rationalize the numerator. So it's the same values that were under the radical in the numerator, except now instead of radical minus a radical, we're going to multiply by radical plus a radical. None of the signs under the radicals change, but what this will do, it's the product of sum and difference. The middle terms will cancel out, and I'll get the difference of squares. Okay, so this is some good practice simplifying with radicals. So we rationalize the numerator and denominator. As I said, we get the difference of product of sum and difference is the difference of squares. So now we get down to this step. I've distributed the negative sign. I can now cancel any like terms. The x's cancel out, 2's cancel out. Hey, I'm now left with an h over an h, so I can cancel out these. Again, that was h times this entire thing, entire factor. So now I have 1 all over, and now once I do that, by getting rid of that h, I can now just do direct substitution. Place c and h, substitute in 0, so we get 1 all over square root of x plus 2 plus square root of x plus 2, and I have 2 of them. And what did I just find? I just found that the derivative, or f prime of x, equals 1 all over 2 times square root of x plus 2. Okay, next we're going to do this rational function, so we're working with some fractions. 3 over x plus 2, every place c in x, I'm going to substitute in x plus h, and we're just using this difference quotient. Okay, so it's f of x plus h minus f of x all over h as h approaches 0. So now I have to do some simplifying. How do I simplify this? I need some common denominators. Okay, so on the second one, we need to get common denominators. Once I get the common denominator, I can simplify in the numerator. I'm almost there. It's all over h, and I wrote it over one as one fraction. Okay, so once I get to this step, I know, hey, and again, how do I get this 1 over h? Dividing by h is the same as multiplying by the reciprocal. Hey, that's nice, because now they're factors. I can cancel those out. Let's keep going. Once I do that, I've eliminated a factor that's going to get us to 0 in the denominator. So now I can just do direct substitution. Once I do that, hey, we get negative 3 all over x plus 2 all squared. So the derivative of that function is negative 3 all over x plus 2 all squared, or we could say f prime of x equals negative 3 all over x plus 2 all squared. Okay, so the next equation is find the equation of the line tangent to the graph of f of x equals square root of x plus 2 at the given value x equals 7. So let's first find what the value of the function is at 7. Substitute in 7, we get 7 plus 2 is 9, square root of 9 is 3. So the point of tangency, again, that one point where the tangent line is going to be, is at 7, 3. So what do I do next? Remember, derivative is equal to the slope of the tangent line. Slope of the tangent line is equal to the derivative. So let's look at what the derivative is going to be, and I found that that's what I found up above. I forgot where I got that from. So now I replace c and x. I'm going to substitute in 7. 7 plus 2 we said is 9. Square root of 9 is 3. 2 times 3 is 6. So we just found that the derivative is 1/6, and the SOT, the slope of the tangent line, is 1/6. And then I'm putting down below, it says find the equation of the tangent line. I'm using point slope first, y minus 3 equals 1/6, x minus 7. On the AP exam, just leave it there. Save time, don't make any mistakes. For what we're doing now, let's simplify, because next it says use a graphing calculator. So I'm going to use the calculator, so I need is y equals. So hopefully we got both of those. Let's do the next one. So the next line, first thing I'm going to do is find out where the point of tangency is. How do I do that? I just substituted my value into the original function. And again, I'm trying to find out where that point of tangency occurs. So I'm letting x equal 1, and I'm substituting in, and I find out that y equals 1. So it's going to touch the point at 1, 1. And next, I'm going to use I found the point, so now I want to find the equation. So what do I need for an equation? I need a point and a slope. So I'm going to find the slope of that tangent line. How do I do that? That's equal to the derivative. So we found the derivative up above. Substitute in 1. 1 plus 2 is 3. All squared is 9. And this was, so it's negative 3 all over 9, which is negative 1/3. So that is the slope of the tangent line. So now let's write my equation. So I get y minus 1 equals negative 1/3 x minus 1. On the AP exam, I would be done. But for what we're doing right now, let's just take the 30 seconds to simplify it and put it in a slope-intercept form. Y equals negative 1/3 x plus 4/3. Okay, use the calculator, graph the original function, graph this line, and show that it's a tangent line. Okay? All right, so I'm sorry this next one on your package is sideways, but we got it right side up. So we found derivatives of several functions and evaluated that derivative at certain x values. What does that give us? When we're talking about derivative, that's the slope of the tangent line. So let's look back at what we've already done, and we're going to fill in the paperwork here. So they gave us a function. Let's put what the derivative is. Again, we already did it. We already evaluated at this x equals negative 1, and then let's find the value of the limit. Okay? So for this first one, we found that the equation of the derivative is negative 2x plus 4. So we started with a quadratic. We did that already. Then we found the value of the derivative f prime of x at negative 1. We got negative 2. And then we find the value of the limit, which is the difference quotient. So, and this is as x approaches a. So here was my a value. I substituted in. And we finished it below. So when we come down here on the right, hey, we find that's also negative 2. Interesting. Let me just show you that works. So if you're writing this down, and the last one, hey, we find the derivative is 1 all over 2 times the square root of x plus 2. We found the derivative, or the value of the function is 1/6. How do I get that? I just substituted in to my derivative. I replace c and x, I substitute in 7. 7 plus 2 is 9. Square root of 9 is 3. 2 times 3 is 6. So we get the value of the derivative is 1 over 6. And now let's use the limit definition of the derivative. So now we have to rationalize the numerator, square root plus square root down here. So we're going to get a difference of squares. When I do that, I get x plus 2 minus 9. Hey, plus 2 minus 9 is negative 7. Those cancel out, so I get 1 all over. The radical plus 3. I can now go right to direct substitution. Square root of 7 plus 2 plus 3 is, square root of 9 is 3, plus 3 is 6. Hey, same thing. Let's come back up and look. So over here, we still got negative 2, and over here, we still got 1/6. So now I want to be able to say, hey, what can we come up with? We're talking about the limit of f of x minus f of a all over x minus a as x approaches a. What does that represent? And we're going to find out that this is the alternative form of the definition of a derivative. So the last part of this page, what does it represent? It represents the slope of the tangent line drawn to the graph of f of x at x equals a. And I believe we only just have definition of the derivative, then the alternate form of that, and then we are done. Okay, last thing is definition of a derivative. So this is the difference quotient. This is one of the first ones we dealt with. So this is h approaches 0. So what we get here is this is a function that's called the derivative that can be used to find the slope of a tangent drawn to f of x, a function. So we looked, hey, when f of x was a quadratic, then the slope of the tangent line was represented by a linear function. If we have a cubic, we're saying it'll probably be 1 degree less. We'll end up with a quadratic. So this is a function where the alternate form of the definition of the derivative, this is x approaches a. So I'm actually putting in the value here And what am I going to get? I'm going to get a value that is the slope of the tangent line drawn to the graph of f of x at a specific value, x equals a, x equals 3, x equals negative 8. Okay? Now, just up here, when I use this definition, I still could get a constant. So if I start with a linear function, the derivative is going to be a constant. That doesn't mean I use this form. So just be aware of that.